Okay, today we're going to be talking about 8.5 solving proportions using cross products. On Friday I taught you two separate methods. Today I'm teaching you a third method, and this is all for how to do proportions. The first thing we're going to talk about today is what cross products are. If you remember from Friday, I told you that whenever you have a proportion, it's two ratios that are set equal to each other. So 3 is to 4 as x is to 10. Using cross products, another way a lot of people call this is cross multiplication. So basically what you're going to have to do is you're going to have to multiply by the number that is diagonal or across. So for this we're going to be multiplying 3 times 10. Now 3 times 10 is going to equal something else that is also diagonal from each other. What other numbers are diagonal from each other? The 4 and the x. Okay, so this basically means right here what you have to do is multiply those because it's a cross product. That means we're going to be multiplying 4 times x. What is 3 times 10? 30. What is 4 times x? 4x. Okay, so now your entire goal is going to be to get x by itself. But there's a number there that's not allowing the x to be by itself. What number is that? 4. A 4. Whenever you have a number directly next to a letter, what sign is it doing? It's multiplying. So how do I get rid of multiply by 4? Divide by what? 4. Divide by 4. If I do it to one side, I've got to divide by 4 on the other side to be fair. What is 4 divided by 4? 1. So these cancel each other out, and I'm left with 1x, or plain old x. And what is 30 divided by 4? 7.5. So you just found out using cross products that x equals 7.5. When you're doing cross products, there is a way to check it, okay? Basically, I can re-plug back in what I've got over here. I had 3/4 equals x over 10. I figured out what x is. What is x? 7.5. So I could do 7.5 over 10. Plug this into your calculators. What is 7.5 over 10? What was it? 3/4. So when you reduce 7.5 over 10, it equals 3/4. Is that what I wanted it to equal? Yes, it is. You look like here, you want those to equal each other. So that shows you 7.5 was the correct answer. Now, when you're working out your homework tonight, you do not have to show me this part as part of your homework, but it's a great thing to do in your head to help you know if you got the answer correct or not. Number 1 says, use the cross products property to solve the proportion. So on your quiz that you're going to have on Wednesday, the whole thing is going to only be about proportions, and it's going to be figuring out which way you're going to use to solve the proportion. Last week I taught you about equivalent ratios. We also talked about algebra. Today we're talking about cross products. On the quiz, you're going to have to specifically use the method that I've asked you. Some of them, there will be questions that ask you how to find it, and you can choose whichever way you want. But some of them are going to be specific. So for this one, I'm being specific. I want you to use cross products property. So the first thing you're going to do, I'm going to start always with my top number right there. What am I multiplying that top number by? 2 times d. Okay, what am I going to multiply the 9 by? 3. You're multiplying across from each other. So I've got 2 times d equals 9 times 3. What is 2 times d? 2d. What is 9 times 3? 27. Do I have d all by itself already? No. Kayla, what do I need to do to get d by itself?
Divide by 2.
Divide by 2 on both sides. These 2's cancel out. I'm left with d equals, what is 27 divided by 2? 13.5. Your whole goal was to find out what d was, this d right here. So I want you to check to see if that makes sense. Plug your answer back into that original thing, 3 over d, to see if it equals what we want it to equal. 3 over d, so you're just plugging in 3 over 13.5, and what do you get?
The fraction I get?
2 over 9. This right here, what does that say? 2 over 9. So does 2 9ths equal 2 9ths?
Yes.
Yes, it does. So it checked out and it makes sense. Problem B says 2.2 over C equals 5.5 over 11. What should I do for my cross products? What am I multiplying by first? I always want you to start with this one. So what does that multiply by?
2.2 times 11.
Okay.
2.2 times 11.
And what is C going to multiply by?
C times 5.5.
Okay. So you're going to set those equal to each other. 2.2 times 11 equals 5.5 times C. What's 2.2 times 11? 24.2 equals, what is 5.5 times C? 5.5C. My whole goal is to get C by itself. Jakari, what do I have to do to get rid of that 5.5? Good job. Divide 5.5 to both sides, because what I do to one side, I have to do to the other. These ones here canceled out. I'm left with plain old C equals what, guys? 4.4. Is there a way that we can check this to see if it's right or not? There is. How do I check it? 2.2 over 4.4. Okay, you're going to see what that would be when you reduce down. What is 2.2 over 4.4? 1/2. All right, now, does this one right here say 1/2? No, it says 5.5 over 11. But let's put that into our calculator and see what it comes out if we reduce 5.5 over 11 to see if it happens to be the same thing as 2.2 over 4.4. What is it? 1/2. Does 1/2 equal 1/2? Then you know you did it correct. And that is how you use the cross products property to solve a proportion. Let's do another example. Okay, so here I've got a graph, and this graph shows how much a 105-pound person would weigh on the Earth. That same person does not weigh 105 pounds on the moon. How much do they weigh on the moon? 17.5 pounds. So if you want to make yourself feel good, you should just go to the moon, weigh yourself there, and you'll be a lot less than you would be here, okay? So we can imagine here, I've got a dog, a 60-pound dog that also travels to the moon. Do you think that dog is going to weigh more on the moon or more on the Earth?
More on the Earth.
He'll weigh more on the Earth, because if a person weighs more on the Earth, then that dog is also going to weigh more on the Earth, okay? So here's what I've got. My question says, use the graph to find the weight, W, of a 60-pound dog on the moon. So I've got to set a proportion here that they are equal to each other. The first one is going to be 105 pounds over what? 17.5 pounds. Okay, you could put the units there, but you just need to make sure when you do your final answer that that's when you've got those units there. Okay, I'm going to give myself a little more room. 105 pounds over 17.5 pounds equals, now, because I have the Earth up on top, do you think that I should put the weight of the dog for the Earth on top or on bottom? On top. If it's equal to each other, then it has to be the same exact thing that I did in my first ratio, okay? And then W is going to go underneath. Now, if you remember on Friday, I taught you two ways that you could also find this. Using an equivalent ratio was the first thing. Can you guys easily figure out how to get from 105 to a 60 by dividing or multiplying?
No.
No, there's not a clear number, so that's not going to be my best way. Now, another way is I could get the W by itself. But if you look, my W is in the denominator, and it has to be in the numerator in order to do it the algebraic way. So what I'm going to do is I'm going to do it using cross products. So if I use cross products, what should this 105 be multiplied by? By the W. 105 times W, or you could just write 105W. Now, what is my 17.5 going to be multiplied by? Okay, I'm doing cross products, so you've got to multiply across 17.5 times 60. There's nothing that I can do yet with 105, so I'm going to keep 105W. What is 17.5 times 60? 1050. Remember, your whole goal is to get the variable by itself. What number is not allowing the variable to be alone? 105. So what do I have to do to the 105?
Divide it by both sides.
divide 105 by both sides. You have 105 over 105, which equals plain old W. What is 1,050 divided by 105? 10. Now, this is a story problem, so I'm going to go back before I just box in W equals 10. My story problem says use the graph to find the weight of a 60-pound dog on the moon. Is his weight W equals 10? What's his weight?
W for 10 pounds.
10 pounds. So you want to make sure for your final answer, wherever it is that you put it, that you have told me it's 10 pounds. And that is the weight of a dog on the moon. Any questions? Okay, let's go to the next one. Problem number 3. There are 5 grams of sugar in 3 teaspoons of jelly. How many grams of sugar are in 4.5 teaspoons of jelly? In order to do this, I want to have a proportion. I'm going to set 2 ratios equal to each other to find out how many grams of sugar are in 4.5 teaspoons of jelly. Who can tell me the first fraction that I'm going to write given the information that my story problem has given me?
5 grams.
Okay, 5 grams over what?
3.
Over 3 teaspoons. Now, I've got to find out what that is equivalent to. Who can help me out with what I should make that equivalent to? What do you think?
4.5 over 2, teaspoons.
Okay, 4.5 teaspoons over what?
Teaspoon.
Over a certain amount of teaspoons.
Okay, since we don't know what the answer is, we're going to do an X. How many of you would agree with this right here, what we've just done?
What? No.
Is there anybody who disagrees with this? Why do you disagree?
Because the teaspoon should be on the denominator.
Okay, she thinks that we should switch these two. Is there anyone who wants to recast a new vote? Do you guys think we should switch it or keep it the same way that it already is?
Keep it the same, because they have the same units and you have to cross multiply to get your answer.
Okay, because we've talked about cross multiply, I think some of you are getting confused today. Watch this. Let's say that I was to, remember how we just had a chart there just a minute ago? Let's say we have a chart that looks like this, grams and teaspoons. Remember, your units need to be put in the same exact place. The first one, I had 5 grams and I had 3 teaspoons. For grams, do I know what grams are for my 4.5 teaspoons yet? No, so I'm going to put it as an X. Do I know what my teaspoons are for the next one?
Yes.
What is it?
4.5.
4.5 teaspoons. Now guys, if you were to set up any kind of a table that looks like this, you would then just use that as your 2 ratios. 5 is to 3 as X is to 4.5. So, is the way that this was done right here, is this correct or incorrect? It's incorrect. So if it helps you, you can always go ahead and put out a table. You can draw a table much like we have right here. If not, you need to make sure that your units are the same. So, great job, Kayla, on that one. We're going to go ahead and go back, and I'm going to switch that. And instead, let me erase this real quick. And we're going to switch this right here. Because if in my first one, I have the teaspoons on the bottom, in the second one, I must also have the teaspoons on the bottom. In order for them to be equivalent, you must have the units in the same spot. And I am looking for how many grams, just like this tells me how many grams. For this, is there any kind of a clear way that I could figure out what I need to multiply or divide 3 teaspoons by to get to 4.5 teaspoons? Does that seem like it would make sense? There's no clear number there, so I know I'm not going to use equivalent ratios for something like this, okay? So instead, what I want you to do, because cross products works every time, we are going to multiply across. 4.5 teaspoons times 5 grams.
What we do algebra too.
Yes, but today we're going to go ahead and just work on the cross products. 4.5 times 5 equals 3 times x. All right, Cheryl, you had told me, what is 4.5 times 5? Okay? 22.5 equals 3x. Am I done? No, I've got to get x by itself. How do I get x by itself? Divide it by 3 on both sides. This one turns into 1x equals what, guys? 7.5. Now, go back through. It's a story problem. Every time with a story problem, you're going to have some kind of units attached. So I always ask myself the question, how many grams of sugar are in 4.5 teaspoons of jelly? So what is my answer? 7.5 grams. So always make sure you've got units attached. Number 4 asks us, tell whether the ratios form a proportion. So for all the other kind of problems that we've had so far, it says something like 2/9 equals 5/16. Well, right now I am trying to find out, do they actually equal each other, yes or no? The way that we're going to do that is by doing cross products or cross multiplication. So the 2 is going to be multiplied by what number?
16.
Okay, so I am multiplying it right there, 2 times 16 equals 9 times 5, doing the cross products. What is 2 times 16? 32. What is 9 times 5? 45. Does 32 equal 45? No. I'm going to put this little slash through it because that means it does not equal, but you're going to write the answer no. That doesn't equal each other. So those two are not ratios that form a proportion. I want you to do the next one on your own. So for your quiz, this is not going to be all about just saying yes or no and just plopping down an answer. You've got to actually show work to show me that you understand what you're doing. The 3, what is it going to be multiplied by for cross products? 3 times 24. What about the 12?
6 times 12.
6 times 12. Okay, what is 3 times 24?
72.
72. And what is 12 times 6?
72.
Does 72 equal 72?
Yes.
Yes. So yes, those two ratios do form a proportion. Any questions about that? Okay, tonight's homework is 8.5, pages 396 to 397. As always, it's just 10 problems, and that is everything you need to know for 8.5. Your quiz over this will be on Wednesday.